I'm ready. Hello everyone, April 21st. Alright, let's do this. I am ready. Oh, actually I'm not. I need to get a drink of water. What is it? It changed. It changed the UI again. Damn. I just can't be changing the UI. Don't they? What is this? Oh, okay. Like what? Oh, now it's infinite scroll. Okay. What are these things? Oh, frequency. Ha. I try to get more. The count again. Jesus. Every single day is count, count, count. All right, let's see. It's pretty early today, so I'm actually in good shape. So hopefully we can get this done. Two integers, n and a max value, which are used to describe an ideal array, a zero-indexed integer array of length n, a zero-indexed integer array of length n is considered ideal if the following conditions hold. Every array I is a value from 1 to max for everything. Every array I is divisible by array I minus 1. Return the number of distinct ideal arrays of length n. Since the number be large, we'll do a modulo. N can be huge. All right, so n equal to 2. So basically we have two values, and the max value is, my handwriting is absolutely atrocious. Come on, let's do it. That's we can do better. I think V is uppercase. All right, so every one is from 1 to 5, and an array I is divisible by the one in front, which means if I choose this is 1, then this can be 1, 2, 3, 4, 5. If I choose 2, this can be, because it times 1 times 2, right? Which is 3 will be 3, but that's it. 4 will be 4, 5 will be 5. So it'll be 5, 6, 7, 8, 9, 10. Okay, let's try another one. So now we have 5. Oh, Jesus. 1, 2, 3, 4, 5. And your max value is 3. Okay, so if we go 3, I go 1. And this I can go, ooh, are we seeing some recursion here? Let's go from right to left. So the last number, we don't really know last number. Hold on. So yeah, so basically, if I go 1, no, last two numbers, right? So like if this is 1, what can this be, right? Because it has to be 2. So basically, if this is a 1, just give me 1, 2, 3, right? So if I say dpi is the number of arrays, okay? Number of arrays in array I to the n. Okay, so I can say this is a 0, 1, 2, 3, 4. I cannot do dp4, but I can do dp3, right? So dp3 is that 1. 2 is actually nothing. 2 is 2. 3 is 3, right? So this is this one. So basically we got 3 plus 1 plus 1. We have 5. It's dp3. Now dp2. So dp2, if I go 1, then I can do 1. And I can do 2. And I can do 3. Ooh, shoot. Okay, so I think it has to be 2 dimensions. Okay, that's fine. And n is pretty small, so it's possible. So dpij then is number of arrays from array I to the end and start with j. So in this case, we say dp 3. We cannot do 0 because we don't have 0. So dp3 1 is 3. dp3 2 is 1. dp3 3 is also 1. All right. So now we want to find dp2. So I can say dp2 1, right? dp2 1 shall equal to dp3 1 plus dp3 2, right? Because it's 1, you can do 2, and plus dp3 3, right? And then we say, now let's delete all that. And then we can say dp2 2, right? So if it's 2, then we can only do 1, which is dp3 2. And dp2 3, let's only do 1, which is dp3 3. Right? So this is 1, this is 1, but this is 3 plus 1 plus 1, which is 5. Okay? Now we check this. Right? dp1, I can do 1. So that will equal to dp, 2 1 plus dp2 2 plus dp2 3. Right? So that 2 1 is 5 plus 1 plus 1, this is 7. And then of course we have dp1 2, which is equal to dp2 2, right, which is 1, and dp1 3 equal to dp2 3, which is also 1. Okay, so that's that. Now we do the final. dp0 1, basically you add them together, right? So 7 1 1, that is 9. And then dp0 2, that will be 1. And dp0 3, that will be 1 as well. So added together, we have 11. Okay, so that is basically how it is going to be. Now the question is, if I really do it that way, what is the runtime? The runtime, I mean, you have this dp, so you have to go through every single one, so that's n. And for each one is the max value, so n times the max value. I don't think it's possible to do it that way, though. But there is a repeated pattern, right? There is a repeated pattern. We go there one more time. 1 2 3 4 5, right? So you have to compute this. So this is 1, right? So basically this is 1. How many is this? That's just the max value, right? That's just max value. So in this case, max value is 3. So this is just 3. Okay, 1 is 2. This is going to be max value divided by 2 because you go 2 times 1, 2 times 2, 2 times 3, right? Basically, you want to see how much you can reach, right? Because you start from 2, which is always going to be good, and then you'll double it, right? and then you double. So what is the maximum value you can get? Well, the maximum value you can get is the max value divided by 2, right? That's the max you can get, and we have to do the integer division. So this is basically 3 divided by 2, which is 1. And then you can do 3, which is 3 divided by 3, which is 1. So by doing this, you immediately can get the total, right? So you get a total, which is yeah, that's that, right? And moving on, when this position on 1, so now I need a sum of this, right? So you'll produce the sum, and when this is equal to 2, so you need to produce the sum of, 2, 4, something, 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 right? Yeah, but that feels still like at each position, it's like you can, as I'm going through, this will go through the max value, right? I go through max value. I can go through it once. I pick out everything that needs to add, right? I can add by 1, I can add by 2, I can add by 3, like 3, 6, it's 9, like we can do all that, and you add them together, they will become the basis for the next round. And the next round I come for this, I will use that, right? And then I come the second one, I will use that. The third one, I will use that. But as this is, we continue adding. But the question is, if we do this, we have to go through every single one, which is go max value times, and then we do max value iterations, n iterations. So it's n times max value. The constraint pretty much says you can do this 1, 2, 3, 4 and 1, 2, 3, 4, right? That is going to take a long time if you really, yeah, that's not happening, right? Which means there is a better way. What is the better way? How can I quickly find out? So yeah, so I have 3, 1, 1 basically, okay, so basically at the beginning I have another array, right? Another array, which is I can say from 1, 2, 3 all the way to max value, right? This is another array to max value, and each one has its count. So we have some value. We have some value a1, a2, a3, am, right? We have this value. Now, given this, I want to aggregate it such that I know, right? This is at this level, right? So at this level, right? At this level, like this is basically adding everything together, and this is adding 2, 4. Is that every second one, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so first add, the next one will be adding 2, 4, 6, 8, 10. Next one will be adding 3, 6, 9. Yeah, if you have next one, then we'll be adding 4, 8, 12, right? So you just keep adding this. How can I How do I know? How do I add them faster? The way this is going, it feels like you should just traverse it once and then you should be able to do this. Or at least, you compute it, you compute the this state, and then you just update as we move to the left. But Lord, how do we do that? Yeah, mind you, you have to go through every single one, right? So you add them together, and then for 2, you add everything, and then for 3, you add everything. For 4, you add everything into a new array. For 5, for 6, all the way down to... Oh, well, technically, once it reach above a certain level, you won't... Oh, it's actually not ONM, because when it's 1, yeah, you go through the whole thing. And we can avoid going through the whole thing. That would be very helpful. Like, how do we do it once and then we can make every computation? I don't think that's possible, right? You go through everything, and then for 2 you go through everything, for 3 you go through everything, but you won't be going through everything. Like, once it's beyond a certain level, right, like halfway, right, halfway point, because before the halfway everybody will have yeah, so basically it'll be all ones, and then all the other you have some numbers, number. Yeah, you have that, and then that's the first level, and then you go to the second level. You will add everything together. Okay, you add everything together, and how do you find 2? You can't just okay, I add it again. How do you find 3? You add again. 4, you add again. 5, you add again. So every single time you have to add. Now the number of times that you're adding is reducing, but you still have to add everything. So that's actually okay. And then you move on. Then you have to add again. You have to add every single time. You have to add again. I wonder if there is a better way to do this. Like maybe some pre-computation magic, or if I know how many times a number will be added, then I can go through everything and then just add that number of times. That ensures that that ensures O n times m, right? That ensures O m times n. But how do we know how many times that we need for each number to be added? I think we need another simulation. Okay, I just do one more time simulation. So 1, 2, 3, 4, 5. Okay, so we just use A1. Yeah, we can say we have A1, A2, A3. And A1 is equal to 3, A2 equal to 1, A3 equal to 1. Okay, so when we are here at this position, I can call it B1, B2, B3, right? C1, C2, C3, D1, D2, D3. All right, so B1 shall equal to A1, A2, A3. B2 is just A2, C2, B3 is equal to A3. Now, C1 is going to be this plus this plus this. So we calculate, so A1 plus 2A2 plus 2A3. And C2 is equal to A2. C3 is equal to A3. And D1 is, you add them together, A1 plus 3A2 plus 3A3, right? And D2 equal to A2, D3 equal to A3. Now you add them together, which is the next one which doesn't exist, which is E1, which doesn't exist, but that's A1 plus 4A2 plus 4A3. So if we expand it as 3 times 4 times 4, that is 11, right? So we just need to find this pattern, right? We just need to find this pattern. So B1 is always this. B2, it depends, right? I mean, essentially, we can rewrite this. B1 is A1, A2, A3, all the way to AM. B2 is A2 plus A4 plus plus AM divided by 2, right? B3 is A3, A6, A9, AM divided by 3, and then B4 is A4, A8, A16. Actually, we should do A6, right? And this will go to AM divided by 4. Whatever, right? Whatever. And then eventually will be at a certain point it don't grow anymore. Okay. So now we need to add them together. So A1 only shows up once. Okay. A2 will show up twice. A3 will show up twice. A4 will show it. Wait, A3. Yeah, A2 is only, 2 times. A3 only 2 times because it doesn't, A3 doesn't exist here, so A3 is 2 times. Now A4 we have one here, and B can have a 4 if I get to 4, right? And this also 4 can have 3 times. 5, it depends. So what I'm saying is, depending on what value it is, we can find out, right? Let's say the maximum value is 4, right? Let's say m equal to 4, right? If m equal to 4, then this doesn't exist. This doesn't exist because 4. Oh, it's not 4 divided by 2, right? M is 4. I can have A2, I can have A4. It's not divided by 4 though. It's m divided by this times this, right? We'll have to redo this. So in this case, yeah, this doesn't exist, and A4 is just A4, right? So we can actually produce this thing, right? And then we can say this equal to this, this equal to this, this equal to this. So when we add them together, what we get is A1 plus 2A2 plus 2A3 plus 3A4, right? 1, 2, 3. We have place 3A4. and that's like as B1 is this, B2 is this, B3 is so this is actually C1, right? C1 is you add this together, and the C2 is, you know, B2 plus B4. B2 plus B4 is A2 plus 2A4. And C3 is B3 is A3. The C4 is A4. Right? Okay, so I don't know. Do you find any pattern here? Anyway, so we got the D. Okay, the D1 is adding all these together. So again, it's A1 plus 4A2 plus 3A3 plus 4A4. Right, so A1, 2A2, 4A2, 3A3. Oh no, that's 3. That's 6A4. 6A4. And D2 will be C2 plus C4. So D2 will equal to A2 plus 3A4. D3 will become A3, D4 will become A4. So now E, but basically we just add them together. Just A1 plus, we have 4A2, 5A2, right? And then 3A3, we have 4A3. A4, we have 6, 9, 10. 10A4. So A1 will equal to 4. So basically just 4A2 as a 2. So 5 times 2 plus 4 plus 10. This is 4. This is 10, 20 with 28. This video is n equal to 5 plus 4. Is that 28? $26. Well, somewhere along the way, I think some computation is wrong. But you need to find a pattern. I still haven't found. I haven't found a pattern yet. Well, the pattern is A1 only show up once. Okay. And so once you combine, right, A2, each one will add 1. So eventually you'll have 5A2. And A3, you have 2 have A3. So why is that not the same? And A4 appears 3 times. Okay, let me do that one more time. Hold on. So we have 1, 2, 3, 4, 5, right? So we have A1, A2, A3, and A4. So B1, right? So this B, C, D. Wait, hold on. That is A1. Okay, so hold on. Let me redo this. So we have A1, A2, A3, and A4. A1 is 4, A2 is 2, because we can do 2, 2, 2, 2, 4, right? 3 is just by itself, 4 is by itself. Okay. So now here, B1. This is B, C, and D. So B1 is A1, A2, A3, A4. B2 is A2, A4. B3 is A3. B4 is A4. Okay? So that's B. Everybody just add on ones. Now C1, of course you add them together, so we have ones, and then B2 will only show up here and here, so it's always going to be 2A2, A2, 2A2. Now A3, I have 1 here, and I have 1 here. So I have 2A3 and A4. A4 show up 3 times, so I have 3A4. Okay. Now C2 is going to be B2 plus B4, right? B2 plus B4, so it's A2 plus 2A4. C3 is equal to A3, and then C4 is equal to A4, right? Okay, now D1, as these things are added together, so A1 plus A2, so we're 1, 2, 3, right? I have 3A2 and 3A3, right? So you follow the same pattern. And this will be this plus this plus this. That's 6A4. Ugh. And then D2 will be this plus this, so that will be A2 plus 3A4. And D3 is A3, and then D4 is A4, right? Now we do E. Basically, we just need to add them together, right? So add them together, we have A1, and the pattern is always 4A2, 4A3, right? A3, A4, we have another occurrence, and that occurrence is also increasing. So that A4 is going to be this plus this plus this. That is 10, right? 10A4. Isn't that the same as what you got last time? Oh, I did 1A2 too much. So it should be 4, right? So now it's be 4 plus 8 is 12, 16, 20, 26, right? So yeah, we got this, but we got this. It doesn't mean that it's within the time. I feel this is gonna time out, right? This is gonna time out because every single position you have to go through this, and I'm trying to see if there is a pattern. For example, A1 always occurs once, right? A2 always occurs the number of times, n minus 1 times. So this is like certain. And A3 is also going to occur that number of times. A4. That's interesting, right? A4. How many times A4 shows up? Well, this is one time. And I'm going to see that's plus 2 because you have these two. And here plus 3. No, plus plus 3. And then plus 4. So 4 shows up, the time is 1. 1, 3, 6. 1, 3, 6, 10. You can see the difference is 2. Difference is 3. Difference is 4. And next time difference will be 5, right? Yeah, because next time this will be 4. So next time will be 15. Okay, that's 4. And every single value will have this pattern. We just need to find its pattern, right? Okay, so the pattern for A1 is going to be 1, 1, 1, 1, da, 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 da. Pattern for A2 is 1, 2, 3, right? So 1, 2, 3, da, 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 da. And till I think it's n minus 1, right? Yeah, n minus 1. And this is just going to be 1 to the end. A3 is also 1, 2, 3 all the way to n minus 1. A4 is 1, 2, not 2, 1, 3, 6, 10, 15. Well, we need to figure out how this one goes. Now A5, what's A5? Well, A5 is if we have A5 here. Yeah, A5 will happen when the max value equal to 5, right? Max value is equal to 5. Well, this is going to be 5. It doesn't matter what this is. It's just going to be 5. So B will have an A5. And B2 will not have 5 because it doesn't reach. B3 will not be 5 because it doesn't divide, right? 5 divided by 2 is 2. 2 times 2 is 4, so it doesn't reach, and B5 equal to 5, A5. So in this case, we have that exactly the same as a A3 scenario, right? So we have a 5, and then when we add together, that's a 2A5. And then we have nothing, and then we have C5 equal to A5. So now this is going to be 3A5, this is going to be 4A5. So 5 will be 1, 2, 3, all the way to n minus 1 as well. Now A6, this will be interesting, right? So A6 will start n equal to 1 is a special case, right? N equal to 1 is a special case which just equal to that number. N equal to 2, right? That's n equal to 2. We just need to add these values together, right? So A6, okay, so we have A6. 6, then B, this one will have. So you basically have A6 here, right? And this will have another A6. 4 won't have, so we'll have B6 equal to A6. So basically in one iteration, we go 1, 2, 3, 4, right? Would be 4A6. So basically we start from 1, now we get a 4, right? So we increase by 3. So the next one, again, this will have, you know, a B6, right? A B6. So we're gonna have a so C2 is gonna be B2 plus B4 plus B6. So that's 2A6, right? So B6 is going to be 2A6. And this C3 is going to be B3 plus B6. So that equal to 2A6. This C4 is going to be A4, C5 going to be A5, and C6 equal to A6. So look at this. All right, look at this. At this level, like at the next level, so you have 1, and then the next level is this is 1A4. At the B, you already have, at the B you only have 1A4, right? Yeah, B you have 1A4. At the C you have 3A4. Now here we just have 4A6, right? We have 4A6. That's what we get. We get 4A6. So the next level, we add them together. We have 4A6, 4, 5, 6, 7, 8, 9. So the next one we get 9. What's the next one? Well, essentially this we're saying we got a 9A6, right? And here we are doing 2, 4, and 6. So we got 3A6. This is gonna be a C3 plus C6. So again, we have 3A6. This is just this. So D4, D5, D6 equal to A6, right? So now at the end, what we have is gonna plus 9 plus 3, that's 12, 15, 16, A6. So we do a 16. So the difference is 3, 5, 7. This difference is 2, 3, 4, 5. Yeah, let's see if this is correct. Okay. So if it's 6, then what we have here is going to be be 6. That'll be 3 because that's 2, 4, 6. That'll be 2, 1, 1, and 1. Right. So A1 is 6. This is 12, 18. 18 plus 8, right? 18 plus 8 is 26. 26 plus 10 36. 36 plus 4 is 40. 40 is 56. 56. So 5, 6. I think 5, 6 is 56. 56. So that's right. Okay. Now we have 7. Well, 7 is a prime, so I think if it's a prime, it's gonna go like this. Because if it's a prime, 7, none of these can be divisible. So we only show up once here, and then the next time we show up here, and then we have another A7, so we get 2, 3, 4. So 7 is just like that, right? Now next one's 8. How are we going to do with 8? So with that, we don't have to write everybody else. I think we have solved everybody else. We just need to focus on 8 by itself, right? So if we focus on 8 by itself, what we have is, we can just remove everything. 8, right? 8. You know what? I don't think that's the right way. I think we should just add a new page. So yeah, we are focused on 8. So we still have D, C, B, A8, right? So 8, first level, we only show it once, right? So for B, B1 has an A8, B2 has an A8 because it's divisible, right? This divided by this is divisible, so I can do B3 doesn't have it, B4 has it, B5 doesn't have it, B6 doesn't have it, 7 and then B8. So basically we have 4 of them, right? 4 of them, which means when we go to C1, we're gonna have 4A8, right? C1 will have 4A8. C2 will have, so C2 is gonna be 2 for 8, so C2 has 3A8. C3 doesn't have, C4 is gonna have 2A8, and C8 is gonna have 1A8. Let's backtrack in here. So we are dealing with 6, right? 6, 2 will have a 6, 3 will have a 6, and 6 will have a 6. So because of that, we have 4A6. So it's very similar to here, right? So 1, 2, 3, right? B3 has 6. So yeah, that's that. And then you do this. We just focus on 6. Is gonna be 2 because B2 has a 6. So C2 is gonna be 2, 3, 6. Another 2, 4, 6, right? Okay. So yeah, that's that. And then we have D1, D2, D4, and then D8. So D1 is gonna be just, we add everything together, so it'll be 10A8, right? D2 is gonna be these 3 added together, which is 6A8. D4 is these, so it'll be 3A8. And D8 will be just 1A8. And now we come to E, right? You're adding all of these together. That's 20A8. 20. So the trajectory is 1, 4. I should be 9, right? How did it come to 10? Well, it come to 10 because, yeah, this has, okay, so basically 4, now becoming 10, and then 20. I'm not sure if it's correct, but we can definitely double check. Yeah, so before 4, A4 is 10, A5 is 4, A6 is 16. A7 is going to be 4. Again, 20. So what we're going to do is A1 is going to be, we're doing 8, right? So A1 is 8. A2 is 8 divided by 2 is 4. A3, 8 divided by 3 is 2. A4 is 10 times 2, right? A5 is 4. A6 is 16. A7 is 4, and A8 is 20. So this is 8. All right, what's that? This is 20. So 20, 20, 20. We have 60. So that's 60. This is 12. So that's 30. 30 plus 60 is 90. So this is 98. We actually skip this. We just go directly to 8. Is it 98? Oh shit, 96. Gosh. All right, so somewhere along the line, it's not correct. Somewhere along the line, it's not correct. Let's retrace. Let's see. Okay, let's try the 7. Just make sure that everything up to 7 is correct. 7 will be just for 7. 7 times 7 divided by 2 is 3. 7 divided by 3 is 2. 7 divided by 4 is just 1. So 10, 5, 6, and 7. So this should be 7, right? So this 12 is 19. 19 plus 8, 25. No, 19 plus 8, that's not. 19 plus 8 is 27, right? 19 plus 8, 27, 37, 41, 57, and a 61. So 61. Let's see. 5, 7. Is that 61? Oh my goodness. Wait, hold on. Yeah, I changed my. I'm gonna do this. 5, 2, 3, 4. 5. Hold on. 5, 1. 1, 2, 3, 4. 5, 5, 6. Hold on. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 7. 5, 8. Ooh, we're exceeding. Okay, I don't need this. Let's just go 5, 4, 5, 5, 5, 6, 5, 7, 5, 8. Yeah, this is just trial and error, not really something that I'm proud of. Yeah, it should be 96. This is 61. That's correct, right? So 7 is correct. 6 we know is correct. What is not correct is 8, which means we have some issue with doing with 8, which means this one is not right. So we go back here and try to see how we got 8 wrong. So 8, A1 have an 8, A2 have an 8, A3 doesn't have an 8, A4 has an 8, 5 doesn't, 6 doesn't, 7 doesn't, and 8 does. So basically we have 4 right? So that's why we have 4. And then C2, because 2 go 2, 4, 6, and 8, right? 2, 4, 6, and 8. So C2 gets 3, 8. And C4 gets 2, and then C8 gets 1. Okay, 4, 3, 2, 1. That looks also fine to me. And now for here, so this will be first, we add them together, and then C2, D2 will be 2, 4, 8, so that's 6. D4 will be this together, D8 will be this. Okay, now we add everybody together. I don't understand. This looks good to me. It's 20, right? It looks 20 to me, right? It's just 28, right? 20 on the 8, and then we maybe we add this wrong, right? That's also possible. Yeah, that's also possible. Maybe everything else is correct. It's just we added wrong. Okay, 8. And also maybe the value we got it wrong, right? So 2 is 4, 3 is 2, 4 is 2, 5 is 1, 6 is 1, 7 is 1. So 8, this is 4, 16, 24. 24 plus 8, 32. 32 plus 20, 32 plus 20 is 52. 52, 56, 56, 72, 76, 96. Okay, yeah, this is right. 96 is correct. Okay, 96 correct. But this one doesn't have the pattern anymore, right? So this, because this is 3, this becomes 6, and this becomes 10, right? So, oh, what do you see? I see this one. 3, 6, 10. No, I think we need to figure out how to compute this, right? And like, I know it's 20. What if I have one more? Like, what's the next? Right? What's the next? So like, basically we just want to know at n-1 position what this thing will be. Well, actually I know, because the next will be, so the difference is 10, the next will be 15. Coming. Alright, I'm back. Yeah, so basically, what's the next one? I know what next one is. Next one, 35. I know, because this is a pattern following this. But why? Well, because 8 is double of a 4. That's why. I don't know. I don't know. I mean a6 is double of a3, but we don't do like 1, 2, 3. We go 3, 5, 7, which I don't understand either. Like, can we say, I don't know if we can say, like, if the previous is 20, right? Yeah, this is 20. That's just E1. How do you find E2? Well, to find E2, we need to get 2, 4, 8. We need to get these 3. So you need to know what these three are, right? So essentially, for every number, right? For every number, you need to know. But the number that belong to you is static, right? So yeah, I'm 8, so I know I have 2, I know I have 4, I know I have 8, right? That actually can do. And then I have the previous thing, and then for this one, I know E2. How do you know E2 what it can contain? Well, what it does, E2 is 8 divided by 2 is 4. But we don't so 2 4 8, right? 2 4 8, 2 to the end. So yeah, this is a 10. 4, this is a 4, this is a 1, so you add it together, that's 35, right? I want to walk back at yeah, like if we do A7, right? A7, I know it's a prime number, so I can go B1, right? B1 we get an A7, and then 2 3 4 5 all the way to 7, we don't have any. We go half, and now we have B7 is 7, right? B7 is A7, so that basically means we have 2. And then if we do we can do prefix sum, right? Well, suffix sum, so we have 2 and 1, okay, for this level. So that's at the level, well, it's at the level B. So at the level C, that's going to be this, right? So at the level D, it's going to be 3 1, right? At the level E, that's going to be 4 and a 1, okay? Let's try 6 again. So 6, right? So we have 6. Max value is 6. And max value is 6. So at the B level, we have B1, B2, B3, B4, B5, B6. Right? That is 6. This is at the B level. At C level, we need to produce a prefix sum. At B level is 1, right? And then as we do, we need to we can go 6, 2, 3, and 4. Now B is all 1. This is C level. And then D level is 1, 3, 6, and 10. And the E level, no, that's not right. No, that's not right. 6. Okay, I'm going to do this one more time. 6 is 6. So B level, B6, 5, 4, 3, 2, 1. Okay. So at the C level, C6, How do we find 6? 6 is... So at sea level, it's 4. 5, 4, 3. 3 will be these two. 2. 2. Because this is 1, 2, 3, 6. Right? So 2, it only adds this. So this is actually 2. Because it only had these two. 1 add everything. So that's C. Oh. So it's not even adding everything. How am I supposed to find the pattern? Right? What the hell? Okay, I have 1. 3 can find, so these two add together. And these two add together. And then everybody add together. Nine. Oh. And you have to do this every single time for every number because you need to arrive. Well, okay, prime numbers we can skip, right? But a non-prime number you have to do this. All the ones divisible. Okay, you want to try 8, 9. How about 9? You want to do 9? Yeah, let's clean this one up. Let's just show this much. I'm hell bent trying to solve this one. Okay, what's A9? A9. So for 9, I have 9. 3, 1. Right? Again, we don't need to draw this. We can just start writing. Okay, B level is gonna be 1, 1, 1. C level. So this is gonna be ON. I'm still trying to, so it doesn't matter, D, right? So with this line is all gonna be 1. This one, this will just have 1, so this is gonna be 2, this is gonna be 3, and this just gonna be adding everybody together, right? So this add together, this add together. So I come to E, you add these things together, it'll be 10. So So 10. So this will be 1. Second level, B level, B level. That's not B level. This is a B level. So 3, 6, and 10. Okay. And so 9. So 9. Nine. 9 divided 2 is 4. 9 divided 3 is 3. 9 divided by 4 is 2. 9 divided by 5, 4, 16, 4, 20, 10. So 111. Yeah. I mean, that was the method, but the pattern, I'm still having trouble understanding the pattern. So how would 10 be? Well, 10. Five, 2, 1. If it's 4, it follows the same pattern. So B, C, D, E, right? B is all 1. C is 1. This 5, 10, so that's 2. This 5 doesn't work, so for 2 it's just gonna be 2 and 10. Right, so that's 2, that's a 1. That's not 1, that's a 5, that's a 4. 3 is this, these are together, these together, and this is 9, and then add them together, this is 16. Right, so 1, 4, 9, 16. But how do we generalize this? That's my question. How do we generalize this? I don't know. Like, given this chart, how do I generalize this? We can't compute this for every single number, can we? I mean, 11 is a prime, so we don't have to do anything about 11. Yeah, 12. So 11 is a prime. So that's 1, 2, 3, and 4. A 12. So 1, 2, 3, 4, 5, 6. Right? So yeah, 12 is like that. Given 12, I have this. So can you give me the pattern? Well, this will be 1, 1, 1. How about this one? This, so B will always be 1, right? But again, like this is you can't just do that, because this will count n minus 1 times, and this will be just a total number. So just you have to go through every single one. That's still feel like timeout, right? Oh. Yeah, this will be 2. This will skip, so this will be 2. This doesn't skip, so this will be 3. This is... So how many along the way that's divisible by 2? Well, how many along the way is divisible by 2? So 12 divided by 2 is 6, right? So basically we have 6 numbers in between. We have 2, 4, 6, 8, 10, 12, right? But among these, I can't even like find this is, I mean, yeah, this is 3 because you have, no, 1, 2, 3, 4. This is 4. But I can't even find this. And this will be 6. I mean, this one itself doesn't take a while to compute. I feel we're on the wrong path, because this is really not going anywhere. So 1 stands for? No, A1 has how many 12s? It's just yeah, it's 6 because we have 1, 2, 3, 4, like that. Have 6. That's kind of this layer, right? But the next layer, you need to add these numbers. Like this, you have to add this, 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 this. 3, you have to add these together. Here it is 3, 3. This needs to add this. Just 10. If it's 4, you need to add b1 9. And this will be just adding everybody together. That's 26. We have seen this before. Is it 10? How'd you come with 10? It's this plus this is 6. It's not 10. You see, if it's 4, it follows this. If it's 3, it follows this. If it's 2, and from this to the end, I have 2, it follows 1, 2, 3, 4. If it's 3, it follows 1, 3, 6. One, 3, 6. Because it's 1, 2, 4. Right? It's 1, 2, 4. This is 1, 3. 1, 2, 4, 1, 5. 1, 2, 3, 6. 1, 2, 3, 6 is a 4, following 1, 4, 9. This is 1, 2, 3, 4. No, 1, 2, 4, 8. 1, 2, 4, 8. 1, 4, 9. 1, 2, 4, 8. Hold on. This is this plus this. Huh? That doesn't work. It doesn't work. 8 doesn't work. 8 is 1, 4, 10, 8. What? Oh yeah, because B C D E the 1 1 1 1, and this is opening 1. This is a 2, so we follow 1 2 3. This is 3, but we don't follow 1 3 6. I guess we do follow 1 3 6. But this is 4. But this 4 follows as a 9, but this 4 follows as 10. Ugh. Oh Lord. I'm out of ideas. Hmm. Hints, hints, hints. Okay. Alright, so this idea is completely not right. We have to scratch it and then use something else. Where an ideal array must be strictly increasing, can you use DP to solve it? Combinatorial. Must be strictly increasing. and then you can space other things in between. Huh. So basically, we say 1, 2, 4, 7, 1, 2, 3, 4, 5. So 5. So that's just one way. Oh, max value is 3. Don't even have to. I might have. I don't know why I do 4. Right? If it's 1, it's 1, 2. Or starting with 2 is by itself. 3 is by itself. We also have 1, 3. My bad. Yeah, 1, 2, 1, 3. So this is 1. This is 1. 1, 3. Basically, just say it can be. I can say if I set. If I set 1 at the first position, 1 has to be at the first position, and 2 has like 4 different ways, right? 2 can be here, 2 can be here, 2 can be here, 2 can be here. So you have like 4 different ways, and when I set a 2, everybody in between has to be the same. Everybody in between has to be the same. So yeah, so this is basically 4 ways to do this. 4 ways to do this. Oh, I also 1 by itself. So 4, 4, 8, 9, 10, 11. So 5, we have 1 by itself. And then we can do 1, 5. 2, 3, 4, and 5 by itself. So 1 by itself is 1, this is 4, and this is 1. So that's why it's 6. What the hell are you doing? Max value 4. Yeah, we're gonna say start from 3, right? 1 started here, so we start from 2. Start from 2 with strictly increasing. Alright, that's way too much. I think I'm gonna copy and paste the solution and call it for now. Oh man, this one needs to be really consider. I feel like I'm getting close, but not close enough. Right, not close enough. Yeah, this one needs more think. Like I kind of know what this is, but I